We'll just wait for a few people to turn up, Abby. Can you see the PowerPoint okay on the screen? Oh, okay, let me try again then. Let me unshare it. Now can you see it, Abby? One second. I'm going to be able to see you guys as well. One sec. Right, can you see it now, Abby?
Miss, can you hear me?
I can hear you, loud and clear.
We can see it. I don't know why, but my chat isn't working.
That's okay. I'm just going to swap to another device because otherwise I can't see the chat at the same time. So I'm going to leave this on the screen and I'm just going to, so if you see me looking down, it's because I'm looking at the chat on my phone, basically, because otherwise I won't be able to see the chat at the same time or who's arrived. So let's just hang on. We're just going to hang on and see who else shows up. Okay. Oh, we've got a few people. So welcome everybody. We're just going to wait a couple of minutes to give everyone a chance to come up and then I'll be telling you all about maths studies. Okay, so we've got a few. Abby, Jishan, Kylie, and Shannon. Have you been to any others already today? Right, we'll make a start, I think. So, welcome to AS Math Studies. This year it will be myself and Mrs. Davis that are teaching it, okay? And we often do that between us. So mathematical studies is slightly different to A-level maths. It's equivalent to an AS level because you just study it in a year. Some schools study it over 2 years, but we can get through the content in a year, and then that gives you a year 13 to concentrate on your other studies as well. I'm just going to go through this slideshow, but if at any point you've got a question, then please just either put it in the chat or put your hand up or just speak out. That's absolutely fine, okay? So, okay, so there is quite a lot of content to get through, and some of it will already be familiar with you. So we will look at things that you know already. For example, correlation and regression you will have come across before. So some of it will be a refresher, but then we go on to look at the Pearson's correlation coefficient, which really understands the strength of any correlation that you see. We look at interpolation and extrapolation, which you will have seen before. Probability you will have come across before, and estimation in some guys you will have come across before, but actually the estimation that we look at is more from a problem solving point of view. So for example, we might say estimate how much it would cost to resurface all of the motorway in the UK. So you would obviously use your powers of estimation that you already know, but we look at that problem solving element in terms of making a series of assumptions. So you might estimate, the length of the motorways in the UK. It wouldn't necessarily be spot on. How much tarmac you would need per metre squared, that kind of thing. How long it would take to do, how many men you would need, the overall cost. So there's lots of elements to that. So an application to a real world situation. We'll look at analysis of data, which you would have seen some of that before, obviously, sampling, interpretation of graphs and diagrams, but we go on to critique the data and look at the reliability of it. And then there's some financial maths in there, which will be really handy as you get older, obviously, and you go on to have a job and you can check whether you paid too much tax. So we look at taxation, national insurance, VAT, interest rates, in terms of credit as well, mortgages, how your student loan calculations are worked out if you go on to university. So it's just to give you a better understanding about maths in the real world, I guess, is the idea of the course. Okay, so it is a relatively new level 3 course for students. It's probably been running about 5 years. And it's aimed at those students who have got a grade C or above at maths, but have decided not to study A-level maths. There you go, 2014, that's me thinking it's 5 years, that's 7, isn't it? So it's really been brought in to bridge that gap between the people who don't want to do GCSE, anything past GCSE maths, or do want to do some maths but don't want to do the A-level, they don't feel they're ready for that. So it's an interim level, I suppose. And it's about preparing students for real life. And that's why we've got a lot of the taxation bits and pieces in there and a lot of problem solving. Only 20% of students study maths beyond GCSE in the UK. In Japan, that figure is much, much higher. So it's really to encourage students to carry on with their maths post-16. And like I said, because it's a real life application, it's looked upon really favourably by employers and by universities. So, for example, if you got a 5 at GCSE maths, but when you go on to university, they've said, actually, we're looking for somebody with a 6. If you've studied this course and got a B, then the universities count that as as enough to get onto the university course in lieu of your grade 6 at GCSE. So it's really, really valuable, especially if you're going on to do maybe psychology, which has got a high maths content in it. Okay, so how are we going to study the course? So you're going to use and apply the maths to solve real life situations, like I've said. There will be personal context, budgeting, household finance. All of those things will help you, if you're planning to go to university, living away from home, managing your student loan, making sure that you've got enough money to get you through the term. There will be contexts that are directly applicable to employment, so analysing and evaluating data, financial calculations, mathematical modelling. Then there are the societal context, probability and estimation calculations. They might be related to local or global communities. So when you are studying this course, we look a lot at case studies. So you can really see how the maths that you learn can be applied in a real life situation. And actually in the exam at the end of year 12, you get given a case study ahead of time, and then that case study is used in your exam. So what that means is we have time to sort of predict, if you like, the questions that might come up, and prepare you ahead of time for that. I mean, obviously we don't know the questions that will come up, but in years gone by, there was a question about retarmacking all of the motorways in the UK. There's been a question about the number of strawberries needed for Wimbledon and other questions around the Wimbledon tennis tournament. So it makes it a little bit more interesting, I think. Also, there's scientific context, so sequences, growth scenarios related to the natural world, science and technology. So actually, this course sits really well with if you're doing sciences, if you're doing the social sciences as well as geography. So any course that has got a mathematical element in, it will really support that, as well as if you're doing financial studies, business studies, that kind of thing. Okay, I'm guessing no one's got any questions yet. Right. Okay, so like I said, these are the areas that the course covers: stats and algebra, probability and estimation, data analysis and modelling, financial planning and management, collaborative problem solving approaches and techniques, and using technology and spreadsheets. So there is an element of it where you will need to be au fait with how to use Excel to store data and create reports. But of course, you will have IT lessons in order to help you do that. A lot of this course is about working together and discussion. And sharing of ideas, because especially when we are doing the estimation and problem solving element of it, it's really good to share the ideas that people have about assumptions you might make about a particular scenario. So we're hoping that all the people that choose to do math studies this year will be invested in having a good old discussion during the lesson. Okay, so what advantages are there for studying this particular course? You will be better prepared for higher education and employment. You'll be able to apply your mathematical reasoning to solve real life problems. It will help you to make sense of any data. So, for example, if you go on to study psychology, that's got a scientific element to it, and there will be a lot of data that you need to process. So it helps you to gain a greater understanding of that. Say over somebody who has chosen to study psychology at A level, but hasn't necessarily continued with their maths. You will retain and deepen your mathematical understanding and extend your knowledge. So it might be that at GCSE you were fine with regression lines, but you literally learned them in order to get through that particular part of the exam. But we will obviously extend that learning so you get a greater understanding of, the context surrounding that kind of thing. Okay. So students studying core maths have found it gives them confidence to better understand the mathematical requirements in other A-level and BTEC courses, like I've said. As I've already said, the leading universities endorse the qualifications because they know that it gives students enhanced mathematical skills ready for a degree course, okay, like I said, from humanities to health sciences. And if you choose to go on to, rather than go to university, to do an apprenticeship, then this will show that you are able to apply maths in context, both business and financial context, which will obviously give you a bit of an advantage, maybe when you're applying for an apprenticeship over other students who haven't studied it. So you'll want to know a little bit about the course structure. There are 2 papers that you're going to sit at the end of year 12. One is content that everybody studying math studies covers, okay, because the course is such that there is a core element and then there is an optional element, and as a school you choose which option that you want to do. So we've chosen the stats one to study, but there is also sort of critical planning and that kind of thing in there, but we've chosen the stats option. But the first paper is what everybody across the country will sit. So that includes analysis of data, so types of data which you will have come across before, discrete, continuous, all that kind of thing. Collecting and sampling data, so it will look at, questionnaires, types of sampling, so random sampling, systematic sampling, which you might have done a small element of, but perhaps not so much. Representing data numerically as well as diagrammatically. So that's, you know, your drawing of your charts. And also being able to interpret them. Then there's the maths for personal finance. So looking at percentages, which relates to interest rates and taxation, how credit cards work, how to calculate repayments, and just generally the cost of credit, which can be quite astonishing, really. How to compare, you know, rates with one another to get the best deal for yourself. We look at loans, personal loans. We look at, you know, if you take out a substantial loan, then you only choose to pay back the minimum amount each month. How quickly that debt can escalate. We look at solutions to potential financial problems. And then we look at estimation, so the modelling cycle, as well as Fermi estimation. So Fermi estimation is the example I was giving about estimating how many strawberries they use in Wimbledon over the tennis tournament, or how long it would, or the cost and the time to re-tarmac all of the motorways in the UK, that kind of thing. So a large part of that is assumptions that you would make. For example, with the motorways, you might assume that actually we're going to assume that all of the motorways are only 6 lanes rather than some are now 8 lanes. And it's about making valid and robust assumptions that you can use to back up any calculations that you do. Okay, so that's really quite fun, the Fermi estimation. I really like that bit because it's a bit, it's not necessary. It gives you a bit more scope, I suppose. So your answer might not be exactly the same as somebody else's, but your assumptions might be slightly different. And as long as you can justify your working out and they marry it with your assumptions, then there is that, you know, that a bit of fluidity in those areas. But that's the area that means we, you know, it provides a great source of discussion in the class. And that discussion leads to a better understanding about how we make assumptions, because people have different ideas and that really feeds everybody's knowledge, which is fantastic. So each exam is an hour and 30 minutes and is worth 60 marks. You are allowed a scientific calculator. Obviously, I'm going to talk about that in a minute. You get a copy of the preliminary material in advance, like I was saying. And so in class, we can spend quite a lot of time annotating it, trying to predict, you know, what the questions might be, doing lots of different calculations to try and prepare you ahead of time for the exam. When you get to the exam, they will give you a clean copy of the preliminary material. So obviously you can't take anything in, but we should have done a lot of work in class in order for you to feel really prepared and really familiar with that preliminary material, so that really no matter what question they ask you, you're ready to go. And I think that's a real advantage. It's really about showing your understanding of the material itself. Like I said, it will be in a real life context. Often there's a question as well about, you know, maybe looking at data. So it might be comparing, I don't know, how students do in maths and English across the world, and asking you to look at the graphical representations and making statements based on those. You do get a formula sheet in the exam, and there are no optional questions. So every question in paper 1 is compulsory. Okay. So paper 2A is the one that we've chosen to study as a school. That's the statistical content. So we look at the normal distribution and how you can use that to, well, it says calculate Z values, but that's in order for you to make predictions about probability, okay, based on, you know, the mean and the variance, so that's the standard deviation, a measure of spread then, if you like. So I'm sure most of you know, because everyone who's in my class will know I've talked about this before, but that's the way they calculate exam grades. It's based on the normal distribution. So you have this kind of curve. And so, the majority of the students would lie in the middle, and then as you get further in towards the edge, there's much smaller amounts of students or exam marks, whatever you're measuring. And that's a really powerful statistical tool. So it all centers around the probability of an event happening. So then we look at probability and estimation using sampling methods and confidence intervals. So how confident are you that this event will occur? And things like that are used for, like when you get a box of Cocoa Pops and it says there's 500 grams in there. If you weighed every single box, you'd probably find that there are small variations. But so on a production line, that what they would do is, they would take a sample and they would have to be, within a really high confidence, so maybe 99.9% confidence that the weight they stamp on the box is the weight that is in there. Okay, so that's what that's a sort of real life example of that. And correlation and regression, are two events related to one another. We look at whether they're strongly correlated or not. We can use the PMCC to give a measure of the strength of the correlation, and just like you would have done previously at GCSE, you can use your regression lines to make predictions. Okay, so that's paper 2. That's another written exam, an hour and a half, also 60 minutes. You will have your calculator. And also you will also get statistical tables for that, which will allow you to complete the normal distribution element of it. Okay. Right, so it's a linear course. There are any exams at the end. So there's no coursework at all. It's on the usual A-level 5-point scale, so you'll get a grade A to E. In September, there will be a baseline test, so be prepared for that. And it will just be a test based on your mathematical understanding so far to give us an idea of where we need to start with as a class. Okay, so for example, if we were to, when we do regression, how far back we need to go. Is everybody quite familiar with that? Or do we need to go back to sort of GCSE reminders? You will need a scientific calculator. Now, most of you will have the one that you could get in school that are about £10 for Class A1. That is absolutely fine. You could, if you wanted to, purchase the A-level maths calculator because that does quite a lot more fancy stuff. So, for example, it will calculate, normal distribution values for you. It will do regression for you. So it's a bit more powerful. I meant to get mine out of my cupboard to show you. They're about £25 from Amazon, but sometimes there's a real deal on. I think I got mine in Tesco's last year for about £20. So sometimes it's worth holding out for. But it's okay if you haven't got that right at the start of plan. It might be that you want to come to the first few lessons, see the calculator that myself and Mrs. Davis have got, and decide whether or not you're going to purchase one of those. But what you need to remember is if you are doing a course with any mathematical elements, if you've chosen, a geography, psychology, sociology, financial studies, business studies, you will need a calculator for those subjects anyway, okay? So if you were thinking about buying a new calculator, maybe the calculator you use for your year 11 is on its last legs. So, and you're thinking about buying a new one, it's definitely worth considering getting the class with. Like I said, they're about £25, but sometimes you can get them for around 20, and they've been around for a little while now, so there may be a deal to be had. You will be given the mathematical studies textbook. We will provide you with that for your use while you're in school. And then obviously we will just check them back in at the end of the school year. Everybody is expected to have a detailed folder of notes. Okay, totally organised, and we will be doing regular folder checks for that. So what I suggest you do is buy yourself a big ring binder folder and some dividers, because then you will be able to separate out each element of the course and keep it all together, you know, as well as all your formula sheets and that kind of thing. We will also be giving you homework, so expect homework every lesson. Okay. Right. So this is the way we would expect your folder to be organised. And like I said, it will be hard copy, and we would expect you to produce it every so often for us to check. Just to make sure that you're organised, because there's nothing worse than getting to February, you know, when we're starting to think about the preliminary material and your notes are all over the place, you've kept them all in a A4 pad. So the front cover will be given to you by us, okay, that'll be at the front of your folder and updated regularly. There'll be a glossary for keywords and definitions. We'll be giving you a formula book to use in lessons, so you need to bring that to every lesson. There may be an intervention which is going to be individual, so like a Key Stage 5 action plan, which will be from your form tutor. There will be your notes from every chapter. Okay, so exercises that you've worked through, homework, as well as any notes that you take in class. You should have a section for any tests that we do. So your end of chapter test, any half-termly tests that we do. We will be doing past papers regularly. So that you will have an exam section. You might have a section for revision notes, so any mind maps you've done on a particular topic. And we also expect you to keep a note and some evidence of your wider reading. Okay, so it might be websites that you've visited, or you might have printed out interesting articles from the newspaper. That we do basically a section on analysing, you know, the way that data is presented. So it might be that you found a particularly interesting newspaper article that you would maybe query, or you think would be particularly useful. So you could stick that in your wider reading section. So it's really important that your folder is well organised. So get yourself a big leaflet article folder and a set of dividers. Okay. Okay, so has anyone got any questions so far? Please ask if you have. Okay. Right. So this is the type of thing we would do. So, do vampires exist? So, what do you already know about vampires? So, you have to be bitten to become a vampire. That's one thing. They die if they come out in sunlight. They sparkle in the sunlight. They're really hard to kill. They need to drink blood to stay alive. They have sharp teeth. Okay. So those might be just some of the things that you already know, so your prior knowledge. So what we might ask you to do is set up a mathematical model to illustrate how the vampire population increases over time. And we're going to start by considering the first 8 weeks. So you might be thinking, oh, how on earth am I going to do that? So, how many people can a vampire bite in just one night? How long does it take to become a vampire? These might be the questions you would have. So we need to set up some sort of assumptions in order to be able to carry out this task. So what might we assume? So we're going to start with week 0 because we're going to do the first 8 weeks. So in week 0, there is only one vampire, but the vampire's got nobody to bite, okay? So in each subsequent week, we're going to say that every vampire bites one person who isn't already a vampire and obviously turns them into a vampire. Every person that is bitten becomes a vampire themselves. and vampires only come out at night, so they will never die. So these are our assumptions. So our vampire population can only grow, it can't ever deplete. So as long as we've made these assumptions and our mathematical model is based on these assumptions alone, then with the maths that we have done, that on the back of this, okay, it's going to be assessed purely for its merit, okay. It's only if you know, when we look at the exam, if you've added an extra little bit in there, but you've not made an assumption about it, or your maths goes against one of the assumptions that you make. So it's really, we're going to make sure that we are clear and able to state our assumptions really clearly, and therefore use the maths that we learn in order to back that up, okay? So we want to know how many vampires there will be after week 8. So we can draw a table, couldn't we? So week 0, 1 vampire, no new vampires, okay? Week 1, there's 1 vampire, he bites somebody else, so there are now 2 vampires in total, okay? Week 2, we have 2 vampires, they're going to bite another person each, so that's another 2 people. We've now got 4 vampires. Week 3, we have 4 vampires, they're all biting somebody else each, so they create another 4 vampires, we've now got 8, okay, and so on. So each week, the number of vampires that we've got is doubling, because each of the vampires that we had is going to bite somebody else, turn them into a vampire, okay? So you can see that over time, our population of vampires is going to grow, okay? So by week 8, we would have 256 vampires. So if we wanted to plot a graph to show this, it would show exponential growth, okay? So it started off slowly, and then because each week the population of vampires is doubling, it's going to increase and grow exponentially, okay? So what do we think will happen to the population of vampires over the following week? It's just going to keep growing, isn't it? Okay. So you might be able to extend your model to find out how many vampires there'll be at the end of week 35, okay? So you could use a spreadsheet to do that, for example, if you want to do the math. So you can use a spreadsheet. It's a really powerful tool. I don't know how many of you have already got some experience with it, maybe many of you have. But it's basically like a giant calculator, I suppose. But you can create formula to almost do anything. And so, you know, you type in all of this, you basically put numbers into squares, and then you've set up a formula on another cell, you know, that will just churn out how many vampires, the total vampire population at that point, okay? So you can use your spreadsheet really quickly to model, you know, what your vampire population would look at the end of week 35 or week 100 or after 5 years, that kind of thing, okay? So here we are at the end of week 35. That is a whole lot of vampires, okay? So how would it match up to the world population? So the world population is 6.9 billion, okay? There you go, we have got a huge amount of vampires. So that's just a really brief example of how we would maybe use a few elements of the course in a particular situation. So there we would have used estimation, we would have used modelling and interpretation of graphs, we would have used a spreadsheet in order to make predictions. So for each element of the course, it might be that we pull in more than one thing, okay? So then we might ask other questions to work out how many of the world's population of the are vampires, and at what point did the entire population of planet Earth become vampires. I mean, this is just a silly scenario, obviously, but it's quite interesting to see how something quite innocuous at the beginning, the application that we would be able to make in terms of maths and how we would be able to apply what we've learned in order to make a valid prediction. Okay. So in short, I suppose the course is all about maths in context. You will learn lots of new techniques. You'll be able to extend your knowledge on some of the techniques that you know already. And ultimately, for those students who are choosing to do a additional A level that has got a strong maths element, it really will support the maths that you do. And for those of you who aren't, it's just a really nice way to continue the maths that you've done at GCSE. So you've still got that mathematical element to your studies, but not necessarily choosing to do A level maths. Okay. So has anybody got any questions at all about the course, how we run it, what you'll be doing? No? Okay. Well, there's been 1, 2, 3, 4, 5, 6, 7 of us. I hope to see you all in September. If you've got any questions at all, like you go away and you think, oh, I should have asked that, or I've been thinking about this, please just email into the maths team, or just send an email if you're not sure who to contact in the maths team. If you just send an email to Mrs. Pride at the sixth form, she will forward it on to us and we will get back to you. But if not, have an amazing summer, guys, and we look forward to seeing you all in September. Okay, see you later. Bye. Oh, somebody had a question. Sorry, I couldn't see the chat. It's not a difficult course at all. It's really enjoyable, and it does work really well with economics, Rachel. And it's just 1 year.